Okay, on the PS2 Facebook group that we call SIF, after the PS2 news group, Tim Clark had referred to modifying what's called the PD bits on SIMs, for the IBM SIMs that are used in the PS2s. And this is a common thing that a PS2 hobbyist would do on occasion. I've done it for the matter of years with different systems just to get a module more correctly recognized by the system. And we're working from Peter Wentz information on the PS2 news group from years and years ago, and him going through and having a chart online that basically shows how those PD bits are set regarding the capacity of the SIMs and the speed of the chips. Now in this case, I'm trying to work with a Model 70 that is actually what they call the AXX planar. That the CPU is in a complex above the planar, and it can be upgraded to a 46 unit with the correct module and BIOS chips that you change out, basically. So the system only recognizes a 2 megabyte capacity, 80 nanosecond speed of module. And this is, in fact, right here, what I've got in my vise, the correct module for that. I only have one of these. I may have some of these SIM modules in other systems and things like that kind of used up right now. But my intent is to go through and modify some SIMs so I can have a full 8 megabyte of memory on the planar, as planar memory in this case, and that way I won't have to add so many adapters, memory adapters on the system to get up to a good size capacity for these units. So going through and testing with a multimeter, and normally IBM will have these PD bits over here to the side. In this instance, it's showing an R1 as open and R2 as being closed, and there's not really anything else there to identify it. Even on the back side, these plate through holes are open still. So the good way to do is to check with a multimeter, and you put the ground of your meter on pin 72. We're going to go kind of backwards in this case, that this would be the R4 position. Okay, and that's showing an open on the multimeter. The 1 in this case is an open. Okay, we're on R3, and that's showing that that's closed to ground. R2 shows that it's close to ground. And not to lose my place here, R1 is showing as an open. So that's the correct setting that we want on the SIM, is to have R1 open, R2 and R3 closed, and R4 open. So there was a Kingston module that Charles included with the system, and it shows a little bit better on these PD bits in this case. So being R1 being open, R2 and R3 being closed, and R4 being open. And if we were to go through the same multimeter test, we would find that on these PD bits for how it's pinned. And that just means a presence detect. Basically, it's just a loop back that tells the system what module is inserted in that slot. So, interesting enough, I do have a Toshiba 2 megabyte 80 nanosecond SIM. Get it in the vise here. It's going in a little bit harder. And I mean, it's got the correct label on it showing us an 2 megabyte 80 nanosecond module, but the PD bits are set differently than what the system expects, so it flags this as a module that doesn't work. So R1 is open, R2 is correctly closed, so these two are set correctly. R3 is open, which it should be closed in this instance, and R4 is closed, and that should be open. So this is actually inverted. If I were to go through and change this module, I would move this bridge to over here from R4 to R3, just to close it and show how the system to correctly define this module to the system. Now I do have 2 of these modules. I have 4 of the 70 nanosecond module. So if you use a faster speed module, it's not going to hurt the system at all. It's going to, you know, it's faster than what the system requires. So this is a 2 megabyte 70 nanosecond module, and I don't have any real place to put these modules other than in the system. And we can kind of see from here, R1 is closed, and that is incorrect in this case. R1 should normally be open for the module being set as a, to make the system think that this is a 2 megabyte 80 nanosecond module. So we would go through and we would remove the bridge from R1 and move it over to R3. R2 is closed correctly. R3 with the bridge moved over would be closed, and R4 is open. So that would be the correct setting of just moving one of the bridge to that, and that's delicate solder work, a little bit of tweezers and everything else. I've normally used just wire wrap wire, where it's where I kind of have a handle on it to move it in with tweezers, and I solder across that area. Just as long as you're going through and basically putting a wire bridge across that particular PD bit, you're going through and closing that those sense pins in this case. So I'm going to go through. I'll get the soldering iron fired up and probably release a second video just to show the completed results, and we can even put them into the system and kind of show what errors would show up if you have the incorrect module, and then with the correct modules on there, we can go through a memory count of a full 8 megabyte on the system as well. So that's all for now. I'm going to put this video up and go from there. Thank you. Bye-bye.